Welcome to Risk Engineers Talk Governance. In this episode, Richard and Gaye discuss how standards stifle innovation. We hope you enjoy the episode. If you do, please give us a rating. Also, remember to subscribe on your favourite podcast platform. If you have any feedback, we'd love to hear from you. Get in touch via admin@r2a.com.au.
Hi Richard, welcome to a podcast session.
Hello Gaye, we're back again.
We are. Today we're probably going to talk about one of the things that gets us both a little bit riled up, and that's that standards stifle innovation.
Every time.
And I guess this comes from a number of comments and questions we've been asked by chief engineers in organisations that engineers are designing to standards rather than looking at what the issue of concern is and designing to solve that problem, which is what engineers should do.
Correct. And the standards come second, not first.
So there's a lot of frustrations out there with technical-based organisations and chief engineers that engineers are only designing to standards, not actually thinking through the application. It manifests itself in a number of different ways, and difficulties arise because of it. And one of the things that we were just talking about is that standards are lag indicators. They're usually done retrospectively after something's happened.
Yeah, and you want to make sure that after you design something, that you have certainly met what the standards demand, but normally that's the lowest possible framework, not where you ought to be, not what recognised good practice is.
And the other difficulty, I think, is that the world is changing so fast and the standards aren't keeping up with that. And so sometimes standards are being applied to applications that are not relevant or haven't been considered by the standard, and that makes it difficult as well.
Yeah, well, that keeps popping up. I mean, in my role as a chairman of an OC with 271 apartments, it was done originally and renovated in 2000, at least in 1997, something like that. And a lot of the fire protection standards were actually substandard compared to what things are now. But I knew that at the time. I mean, I obviously brought into the apartments 10 years later. But I was aware as a fire engineer at the time what the deficiencies were and what recognised good practice in North American codes were. And so we have this horrible situation that the Australian sprinkler standard, for example, didn't demand a sprinkler in the bathrooms, which is just common sense that if you're going to sprinkle a place, you do it everywhere. But if you're just designing to a standard, you don't.
It didn't have a requirement even so it wasn't done.
It wasn't done.
So, I mean, shortcuts in a way are being taken, and I think the WHS legislation has changed that to a degree.
To a degree, but people still aren't thinking it through.
No, that's correct. And so today we thought we'd go through a couple of examples just to show why standards are lagging and they stifle innovation, and that probably gives the best example of what we're talking about.
And we are talking about design standards here more than anything else. Now, I think we might have used this example somewhere else, but it actually, because of the technology has been moving along so fast, it actually become more and more relevant. Now, you'd be aware that the bane of electrical regulators in Australia is the home handyman getting the roof space, filling with the wires and doing themselves in electrically. And you might recall we had a Royal Commission into installing insulation where a young guy just basically stapled through the metal insulation into the 240 volt wires, and that was the end of them. Now, this has been a pain. Now, even now, if somebody's building a house, what they're most likely to do is build it to AS 3000, which is, I've got to say, as standards go, is one of the more authoritative ways of doing things. But it doesn't address particularly the issue of 240 volts in the roof space. Now, this matter's been going on for some time, but the most recent design approach, particularly in industry, is to put power over Ethernet to luminaires. And you can now get 25 watts, which is a very bright LED, at 48 volts through power over Ethernet. And because of all the other efficiencies and energy savings and so forth going on, monitoring every light fitting has become a sort of a trendy thing to do. Now, if you wire a new house up with 48 volts, which is extra low voltage wiring, there's no possibility of somebody getting killed just from stapling or hacking around up there. It's not going to happen. Is that in AS 3000? No, it's not. Is it required now by WHS and in Victoria the OHS Act? Absolutely. And so if you haven't designed a house now to take this into account, and somebody subsequently gets killed up with a 240 volts when it can be shown absolutely crystal clear for no increase in cost you could have engineered this out, then you've failed the design test because you designed to a standard.
I think the difficulty is that people aren't thinking about it that way, are they? You know, they're still thinking that designing to the standard covers them to do that sort of stuff. And that's what we mean by standard stifle innovation. They're actually not thinking over what could be done and why wouldn't you do it.
Well, that's right. But it's an interesting thing because, you know, you can't legislate for creativity. It's not the way the world works. It just doesn't function like that.
No, it doesn't.
The other example which we had, because we're kind of sensitive to it, was the Wallen incident where the train driver and train pilot got killed. Now, I think we might have mentioned this earlier. The R2A was the functional safety assessor under ISC 6150 Act for how two trains would get past each other electronically in single line track in New South Wales. And they'd had a near miss, and in order to we said, well, you need a diverse or independent way of confirming where the train is rather than just relying on the train driver talking to train control. And the way to do that was to use a GPS function and to have basically a GPS watchdog, which was eventually implemented. Although at the time this was non-standard, and because it was the first job you did and you didn't entirely testing to confirm that every intersection, every crossing loop and everything that happened in New South Wales, the watchdog would work for, which is how we confirmed that it was a robust idea. But then they had generally two independent ways of doing things. Now, because we do a fair bit of work in marine pilotage, and this is a paper you gave to the core conference just recently, an example, the marine pilots now have, and this is technology that's been developed, particularly in the last 20 years, what they refer to as a personal pilotage unit. And the idea is the marine pilot gets on board the ship and whacks their own laptop or iPad, effectively these days, at the centre of the bridge, and then paces out the wing bridge and sticks up a Bluetooth GPS connection. And that means that the laptop knows, these days with the way all the satellite systems are working out there, so you'll be using the Russian system, the American system, the Indian system, the Japanese system, there are so many damn satellites up there now telling you where you are, that this laptop knows to the nearest centimetre where it is without any particular difficulty. And the reason for doing this is that if the ship goes black or a squall turns up and you can't see anything because the windscreen's just got water all over it and the radar's gone on the blink because the radar can't get through it, the marine pilot has a completely and utterly independent navigation system, utterly independent of the entire ship, telling where they are, how fast they're going, what direction they're heading, and all the other aspects. And this technology has become blindingly reliable, very small, and very efficient. It begs the question, why don't interstate trains have this? More particularly, why doesn't a trained pilot, who's particularly there to navigate through the different networks through the state, have this kind of device? Because this would tell you, for example, and give you live real-time messages on the state of the track ahead of you, which is what happened because they were doing some work on the track. And yes, they had been advised before they left Sydney that there was work happening on the track and they'd have to slow down to a 10 or 15k and take the crossing loop around where the work site was at a slow speed. They didn't. They hit the train, hit the work site basically at line speed and derailed, and the train driver and the pilot got killed. We have a view that if you had one of these units similar to what the marine pilots have, that the train pilot and the driver would have completely independent knowledge of where they are, utterly independent of train control and any onboard nav system. And this train pilot system would also have an indication of all the track gangs, track work, and any works ahead of them that they'd be getting real time.
Well, you could put a lot of information in it, isn't it? Because it'd give you pure situational awareness, full situational awareness. And
Correct.
So if the track gang or another train was there, you know, everything's being identifiable now. That, you know, if all of that feeds into the system that gives you a holistic picture of what's around.
Well, that's one of the things, remember, with the aviation sector, they've stopped using radar and they've gone to ADSB. And ADSB basically means that each aircraft is squittering where it is, 10 times a second or 10 times a minute or whatever it is, and basically just reporting its GPS position. And then that information is being fed back to all the other aircraft so they know where they are. There is no reason why a train couldn't have the same technology. The point we're making is that all these new technologies are emerging in other domains. They all have potential application to the train.
Not necessarily just emerging, Richard. I think some of these technologies have been well and truly established.
Well, yes, they've been well and truly established. They're not those. They're robust, proven.
Yes, and whether the application can be varied and expanded to a whole lot of other industries.
Well, you might remember I asked at that conference, just saying, I just asked one of the marine pilot guys, I can't remember if it was the Australian or Norwegian guys, they said, what would a unit like this cost per train driver? And if you had to sort of map where all the rail lines were so you could sort of cross-connect where the position was and so forth, they just sort of said, well, it's probably $3,000 to $5,000 per unit, and it's battery operated and goes for 15 hours for each train driver, so it pretty much covers any rail trip in Australia. And he said, for $50 million, we'd fall over ourselves to do it for you. Map the entirety of Australia.
There might have been a bit of a marketing PR thing in there as well.
No, when I pushed him on the motor, he said we'd probably do it for 25 million.
So what we're sort of saying is just because you design to the standard doesn't mean that you satisfy the obligations, and we've said this a number of times in different podcasts, the obligations, WHS legislation, but it also stifles innovation. And I think that's where some of the chief engineers are getting really cranky at their engineers about, because they're saying, no, look at what the problems are and what they currently are. What are the options that are available to address that issue? And then what is reasonable in the circumstances?
And culturally, this is one of the things that absolutely drives us crackers with Engineers Australia, because basically they're encouraging every engineer to give their intellectual property to Standards Australia for free, with no recognition. They actually breach the Code of Ethics of Engineers Australia, because in the North American standards, they make a point of listing the person, their organisation, whereas in Standards Australia just lists an organisation. You don't know where the ideas come from, there's no way of testing them, and rather than Engineers Australia doing it, which is, if you want innovation where it ought to be, once you start pushing through a standards committee, it's your toast.
Yeah, just stops that innovation altogether, doesn't it?
Yep.
So I guess we there's a couple of be carefuls as we end this podcast. Be careful that you're actually looking at what all the critical issues are, and you're designing to make sure all reasonable practical precautions are in that. And when you take a standard, have a look to make sure that it still actually applies and is applicable to what you're doing.
Yep.
Because we've seen that as well, a standard being applied and the circumstance to which the standard is being applied isn't even considered by the standard.
Correct.
So you need to be really careful of that as well. So we hope you've found this podcast interesting. I'm sure this is one that we will explore in more detail and a number of other times. So thanks again for the chat, Richard.
Thanks, Gaye.